Hi friends, we'll start with the prism. You know what is a prism? It is just a piece of glass with five faces, two triangular faces and three rectangular faces. This is the triangular face which you are seeing. Let us see how light ray refracts when it goes through a prism. First of all, this is the incident ray. Say this is P, and at Q it undergoes first refraction, and at R it undergoes second refraction, and finally you have S here, that is the emergent ray. Okay. Then the angle between the first normal and incident ray, this is angle of incidence and this is the angle of emergence. Now, as you see, it is refracted twice. Now, what happens here is if the light ray, if it had come in this way like this along SR, it would have taken the same path but in reverse direction. Got it? Had we started with S, then the light ray would have gone to R and then to Q and then to P. So, if you start with incident angle I, you emerge with emergent angle E, right? So, if you start with E, you will emerge with I. I mean, the path can be tracked back. Observe one thing. This A, the top angle, is known as the angle of prism. Now, let R1 be the first angle of refraction and R2 be the second angle of refraction. That is actually the angle of incidence for the second refraction. In the quadrilateral AQNR, QN is normal, right? So AQN, this angle is 90. And similarly, NRA, this angle is also 90. So what are we left with? Angle A plus angle QNR. Inside that quadrilateral, their sum will be equal to 180 degrees. Because sum of all angles in a quadrilateral is 360, right? Now, what can we say from this? A is the angle of prism, right? And in triangle QNR, sum of three angles. First angle is R1, next is R2, and the third angle is angle QNR. Sum of these three angles is 180 degrees because sum of angles in a triangle is 180. From these two equations, if I subtract them, what will I get? Angle A minus R1 minus R2 is equal to 0, right? So my angle of prism is nothing but R1 plus R2. Angle of prism is fixed, right? That is something physical. So you can say that R1 and R2 are related in this way. There is something called as angle of deviation, this one. It is how much the ray is bent. That's it. Initially the ray was in this direction, right? And finally the ray is in this direction. So this angle is known as angle of deviation. And how to get it? Angle of deviation is how much the ray is bent, right? How much did it bend for the first time at this refraction point? It bent in this way, I minus R1. By this amount of angle, the ray was bent. And we have to add it with the next amount of bending, that is E minus R2, right? So when you add these both things, this is the angle of deviation, or you can also write it as I plus E minus A, since R1 plus R2 is nothing but angle of prism. Now this angle of prism is anyways constant. A is constant, right? So angle of deviation depends on the angle of incidence. And how, observe this. This will be the graph. As you vary angle of incidence, as you increase it, first the angle of deviation decreases and then it increases. So there will be one angle of incidence where the deviation is minimum, that is dm, that is angle of deviation minimum. And that is the case when the light ray is parallel to the slab or ground inside the prism. So what can I say? If this is my prism, this is the angle of incidence where my angle of deviation will be minimum, where my light ray is parallel to the base inside the prism. Or in other words, this is the case where the angle of incidence will be equal to the angle of emergence. And other than this, for all other deviations, there are two angles possible. I said right, the ray can be retracked in the backwards direction. So when this is the angle of incidence, this would have been the angle of emergence. So it is just the opposite case. The same deviation is found in the other case when the light ray comes from this side. In that case, this will be the angle of incidence and this will be the angle of emergence. So actually our deviation depends on I and D, right? And in turn I and D are dependent in this way, and hence you have this. So minimum deviation will be 2i, because then the angle of incidence is equal to angle of emergence minus a that case. Now let us calculate what it is, because here you know that this is a symmetrical case. I is equal to a, so r1 will be equal to the r2. Let it be r, say. So I can say that my minimum deviation is nothing but 2i minus a, and this implies that my angle of incidence will be equal to a plus dm by 2, where dm is the minimum deviation. And if the refractive index of glass is say n21, that is given by Snell's law, right? Angle of sine of angle of incidence by sine of angle of refraction. So n21 I can measure it experimentally. So n21 is equal to, and sine of angle of incidence, right? Sine of angle of incidence is what? A plus dm by 2 from this equation. Let me write it. A plus dm by 2. This is angle of incidence. And sine of angle of refraction, right? R. Here it is a by 2, because symmetrical case we just discussed now. Let us write neatly. N21 will be equal to sine of a plus dm by 2. This is angle of incidence. And in denominator I have sine r. And all these quantities can be experimentally measured. I mean, by doing some experiments, you can measure the minimum deviation, angle, as well as R. So, using this one, you can find the refractive index of the glass prism. And when prism is something like this, when angle of prism is very, very small, and angle of incidence is also very small, see, then what will happen? Sine of theta can be approximated to theta. Then this can be written as just a plus dm by 2 by R is what? A by 2. So, this is nothing but a plus dm by a, right? Or from that equation I can write dm as n21 minus 1 of a, because this is nothing but a plus dm by a. Just from this equation I can get this equation. So what does it imply? If angle of prism is very small, this one, the net deviation or minimum deviation is also going to be very small. That means ray is not much deviated. It even makes sense, right? Because it appears to be a very powerless prism because it is very small. Dispersion is an interesting phenomenon where the white light spreads out into its component colors. Actually, prism is not the only way to get the dispersion. There can be many other ways also, like best example is rainbow. Rainbow is formed when the light ray gets dispersed through the water droplets which are suspended in the air. There the water droplets acts as a prism. However, the prism can also disperse the light, white light, more commonly known as white light. When white light passes through the prism, you finally get the colors. These are not exactly 7 colors. Actually, there are many colors. Actually, there are many colors. They can be broadly classified into 7 components, and you have a code or acronym to remember these colors. WebJOR, GYOR. Hope you all know this: violet, indigo, blue, green, yellow, orange, red. This phenomenon is known as dispersion. And why does this happen? Is the prism doing something inside, or all the colors were present before only in the white light? To know this, Newton did another experiment. He placed another glass prism in inverted position besides the normal glass prism. What happened? First, the light was dispersed into component colors, and then again it was reunited, or finally you got an emergent white light. And this showed that prism was not doing anything, because if prism was creating colors, the dispersion should be even amplified as it passed through the second prism. So it was not the prism that is doing, it is just dispersing. So the component colors were present in the light before only. Actually, the light has all the colors, white light has all the colors. Then why does this happen? It happens because uh, the refractive index of this glass prism, it depends also on the wavelength of the light ray. So each color component or each wavelength associated with that color has a different refractive index. So each light ray bends differently. I can say that the red bends least because red has the maximum wavelength, and violet bends the most because violet has very less wavelength when compared to the others. So this is how a dispersion happens, and hence red travels faster when compared to other colors and violet travels slower when compared to the other colors. Actually in vacuum all the colors travel with same speed, so that is why you don't see any dispersion there. And why don't we see any dispersion in air? Because air can also be considered approximately like vacuum. That's why you don't see any colors in air. And since vacuum or air doesn't show this dispersion effect, they can be named as non-dispersive mediums. Otherwise, like prism, they would have been dispersive mediums. And that's it for now. In the next video, we'll discuss about microscope and compound microscope. Keep watching. Bye.